so Unit 2, Lesson 2.4. So in this section, we'll develop the formula to derive the product of two functions. It's tempting to guess, as Leibniz did 3 centuries ago, the derivative product is the product of the derivatives. We can see how this guess is wrong by looking at the particular example. So, for example, we know the derivative of x is 1. We know the derivative of x squared is 2x. So 2x times 1 is just 2x, right? But if you do that, what is x times x squared? X cubed. The derivative of x cubed is 3x squared. So they don't match up. So it's not that simple is what he's saying. Okay? You don't just take the derivative of the product. It's not like the sum and difference rule. There is actually a little twist with the product rule. Okay? And here it is. Okay, so the product rule is you have to do the derivative of the first or second, doesn't matter your order, but you have to take derivative of one plus the derivative times the other one. You keep one normal and one not normal. Okay? So we'll do it in a second. The way it's written is kind of written the way I say it, but I would say derivative first plus the second times derivative. Hold on. First times derivative of the second plus second times derivative of the first. That's how you say it. Yeah. Just means you do the derivative one of each, but keep the regular of the opposite. You'll need to see it. It's better to just do than to me speak Spanish. So this maybe right here. So the derivative of the product of the two functions is the first function times the derivative of the second, plus the second function times the derivative of the first. Yeah, that's what I was trying to say. Chinese still. All right, let's get to English here. Okay, so the example would be this. These are a product. So we can't just take the derivative of the left, derivative of the right, times them. You can't do that. So what you have to do is recognize these as two different things. So I'm going to do, for y prime, it's going to be derivative of the first. So what's the derivative of this? Six x squared, right? That's all it is. Plus, you keep the regular. Plus, now you do the opposite. Keep the first one. Take the derivative of the second. What's the derivative of the second? 6x minus, what's the derivative of x? 1. So that's the first step of taking the derivative. So this is, if you want to call this first, we'll call this second. That's first derivative, the prime on it, times the second, times the first, the second derivative. You have to add them together. That's the product rule. That's what I mean by one of each. Now, from here, we want to simplify. 18x4, just multiplying, minus 16x cubed, or 6x cubed, so you're not 16. Just distributing. Got to FOIL this one. 12x4 minus 2x cubed plus 30x minus 5. So from here, we want to combine all of our like terms, and then we'll be done. So I have a 18x4 and a 12x4, so I have a 30x4. I have a negative 6x cubed, a negative 2x cubed, a negative 8x cubed. And then we have the 30x and the minus 5. So that is y prime. That's the derivative of the function above. Yeah, so you're going to do it so much that you don't have to memorize it. Derivative of the first times the second plus the second times derivative of the first. Okay. All right, so let's have you guys try this one. See if you can do this one on your own. So here's your two. That's the first. The other one's the second. So try that. See what you can get. Okay, so, and it doesn't matter the order you do it because you're adding. So if I do the derivative of this one first but not this one, it doesn't matter because it's adding. A plus B is the same as B plus A, right? So don't worry about the order. All right, so what I'm going to do is I'm going to go root x. I'm going to derive the second one, which is negative 3. Plus, the other thing, we know what this is by now, right? That's going to be, hopefully you get it's this, right? derivative of root x. Okay, and then we keep the 2 minus 3x. Okay, so then I have negative 3 root x is what this is. This one I have 2 minus 3x over 2 root x. Okay, we're going to try to get these together, I think. Let me see. Yeah, so we're going to go root x here. So I get negative 3 root x plus 2 root x minus 3x root x all over 2x. I'm going to bust these up into 3 fractions, but to do that, I want to get this also to be over 2x so I can get everything put together. So I'm going to timesing this by 2x to top and bottom. Sure. We're good? So that's going to make the top here negative 6x root x over 2x. Don't cancel these yet. Plus 2 root x over 2x minus 3 root x over 2x. So by doing that, we have these two are like terms. This one and this one are like terms, the 6x root x and negative 3 root x. 3x root x, sorry.
Why do you only multiply by root x and not 2 root x? Because aren't they together?
They are, but the only thing that's bothering us is the root x. If you multiply by 2, it won't change anything. It'll just make your numbers higher. So you can multiply by 2 and still get it right. Okay, and this combines to be 2 root x over 2x minus 9x root x over 2x. Okay, and the last thing we just do to finish off, we cancel the 2's. Negative 6 minus 3 is negative 9, because these are like terms. That's why we were doing this part, yeah. And then our x's cancel, so let's get the 2's cancel here, x cancels here, and we're going to get root x over x minus 9 root x over 2. And root x over x can also be simplified because it's x to the 1/2 over x to the 1. So what's 1/2 minus 1? Negative 1/2, so what would that be? Be 1 over root x. This turns into 1 over root x. This is your simplified fully answer right there. That's as far as you can go. Okay, we got one more. Okay, I'll just pause it for a sec. So last one, we're going to define one more tangent slope here. So find the slope of the tangent to the graph of the function 3x squared plus 2 going through the point 1, 5. So this one's just telling us this point is on there. We're trying to find the tangent slope to that point. So this is where we just take the derivative and then we plug 1 in. Okay, because we're looking at that point. Okay, so that's what we're going to do real quick. Okay, so because we're trying to figure out f prime of 1. Okay, so here we go. I'm going to do 3x squared plus 2, and I'm going to do 6x squared. And then I'm going to do 6x and 2x cubed minus 1. That's the derivative using the product rule. Now we're going to simplify things as far as we can. So I get 18x4 and 12x2. I get 12x4 minus 6x. That gives us 30x4 This is for f prime now. 12 plus 12x squared minus 6x. So this is, and the answer, again, back to what Morgan said, so this is the equation of how we figure out what our tangent slope would be at a given point. So this equation will give us what we want. We just need to know at where. It tells us where, at 1. So all I want to do now is I just put a 1 in here. That's all we do. And so that gives us, and it just says find the slopes. We're not doing the equation this time. So it's 30 plus 12 minus 6. That's going to give us 36 is our slope of the tangent line there. And that's it. Okay. All right.